Okay, so the second of the problems that we listed was finding a minus b. So the vector a subtracted from the vector b, and that is equal to, let's say, some vector d. So how do we go about solving this problem? Uh, let's redraw the figure and see if we can come up with something, some kind of different approach to solving this. Right? So we have the vertical axes, we have the horizontal axes, and we'll switch back to the red pen to draw the vectors. So you have the vector A, and what we can do with the vector B is, if we look at the vector B in this given figure, you see that it's pointing upwards, and that's the positive vector B. So if we were to rewrite this problem as A plus of minus B, then I could just redraw the vector B pointing downwards, right? And then I can just find what the vector D is by going from the tail of one vector to the head of the other, as we always have, and that should be the resultant D. And yeah, so this is the resultant. Now we know that the angle that this makes is 135 degrees, right? And yeah, it makes 135 degrees. So now, using the law of cosines, we can find what the magnitude of D is, just like we did in the previous page. So it's going to be magnitude of D is equal to 13.98 newtons if you go through with the same steps as we did in the previous case. We can write this out as a square root of, just so we remember, this is the magnitude of A, 5 squared, plus 10 squared magnitude of B squared, minus 2 times 5 times 10 times cosine 135 degrees, because that 135 degrees is the angle between A and B, right? So yeah, this turns out to be 13.98 newtons. Also, let's find the angle that D makes with B, and then we can just eventually determine the overall orientation of this thing. So for this, we use something called the law of sines. Law of sines. Right, so this one is sine of beta, where beta is the angle between the vector D and the vector A. Sine of beta over the magnitude of the vector A. Right, okay, let's rewrite that clearly. Magnitude of the vector A is equal to sine of 135 degrees over the vector D. So, or the magnitude of the vector D. So the way we've written this sine of the law of sines, the way it works is, you have a vector, right? So let's say we've identified the vector D. We look at the vector D and the angle that is opposite or right across from the vector D, and it's this angle, right? So that's how I have written the right hand side of this equation. I have the vector D over here and sine of the angle right across from it. A similar thing has been done over here and here. So we look at the vector A, and that's here, and we can take the sine of the angle of the vector A, right? Sorry, the vector B. The vector B was the one of 5 newtons. So you have B and the angle opposite that one. So that's how you write the law of sines. And eventually, if you were to solve for beta, you get beta is equal to 28.5 degrees. So that's how you solve for the angle. Note that I haven't written the law of sines over here in the first problem. So you actually have to find gamma. I just realized that. I just remembered I haven't written that. So if we were to write the law of sines for the first problem, or the first part where we did A plus B, we would get gamma is equal to 28.5. Oh, you can solve for what gamma is here. I think here it's 28.5, sorry. And over here, it's not 28.5. Here it's something else, and I'm going to leave that up to you guys to find. Sorry about that. But yeah, so use the law of sines and find out what beta is, right? So that's a little assignment to do in your homeworks. Or not in your homeworks, but just to do at home right after you're done watching this lecture. Maybe give that a try and see how the law of sines works. And then finally, we have to find what A dot B is. A dot B is basically the magnitude of A times the magnitude of B times cosine of the angle between theta A, B, right? The angles between A and B. And we know that the angle between A and B, when we look at the first figure, is you place them tail to tail and you look for the smaller of the two angles, right? So if you were to take this vector B and shift it up somewhere here, then you would have the angle between A and B. We already know that this is 45 degrees, so therefore this portion is 45 too, plus the 90 that comes from here, right? So that gives you an angle of 135 degrees. So using, sorry about that again, yeah, using the magnitude of A is 10 times 5 times cosine of 135 degrees is equal to, you can fill in the number here. Yeah, so that is how we go about operating and performing some of the algebra that's needed on vectors. With this, we'll call it a day on today's lecture. Tomorrow, or I mean in the next lecture on Monday, the video lecture that you see, we will begin to look at components of vectors and things like that. We will try to wrap up everything that we need with respect to vectors in that class, hopefully, at least for a review on how vector algebra works. I think we would like to call it a day on that. And hopefully get started on the vector calculus part of the review, which shouldn't take too long, I imagine. Hopefully we can do all of that by the next lecture, but if not, we will finish up with all of the vector review stuff by the 13th, which is when we have our first in-class lecture. Anyway, if you have any questions with what you've seen today, please feel free to email me or the TAs. Office hours will start on Tuesday, and I will send out an email, and I will also post the updated syllabus once I have all the locations down for our office hours and things like that. All right. Thank you very much for your patience, and we'll see each other again soon.